I can
Oh,
start with.
all right.
Uh,
So
okay.
you guys can see my screen, right?
Yeah.
All right. Awesome. So
Yes.
welcome, guys, to the first blockchain session for the Association of Information Systems. Just a little bit of who we are. Okay, so we are the largest student organizations focused on business and technology, and our mission is to provide students the opportunity of learning crucial technical skills that will help them establish relationships that will help them grow as professional. So some of the events that we offer are the business analytics experience, where we help them grow as analysts and let them learn everything about how to process data and how to analyze data and how to present the data to any type of thing. Just like a real company, we do the blockchain workshops such as these ones. We do data talks with real experts in the fields, professional developments. We have analyst and blockchain competitions, and also we have a community network that we help out with other professionals so we can grow as better students and better professionals.
Hey guys, my name is Raul Fife. I'm Vice President of Epsilon Pi Epsilon. We are the tech org in FIU, and we have different types of programs in order to keep a range of different types of technologies that you guys might be interested in if you're more technology savvy. So we have UP Design, which is supposed to be a front end and UI UX, UP Mentor, so you can get to know our community in UPE, UP Shell Hacks, where we have the largest hackathon in Florida, UP Spark Dev, where you can work on the project every in a 9-week time period with a group of people. We got UP Advance, which is supposed to be technical and behavioral interview prep. UP Make, which is more for the robotics type of people that want to get into hardware and embedded systems. UP Infotech, that falls more into Linux, DevOps, and cybersecurity. UP Ignite, where you can help out your community by going out and teaching CS to different types of age ranges from K to 12. And UP Code, where we try falling into different types of coding projects like web dev, game dev, mobile dev, and AI. Next slide, please. And in case you're interested in game development, we have the Global Game Jam this weekend, and you could apply in order to participate for that one. Everyone is allowed to participate, and you could use any language to make your own video game over the weekend. It's a 48-hour competition, and I really recommend it. Thank you.
Yo, what's good, everyone? My name is Azarli, and I'm the president of the Developer Student Club at FIU. We're a new club here at FIU, and we have so much that we have to offer to students. So, what are the things that we do at DSE FIU? Well, we offer mainly three different things to offer students of all different majors, whether it be computer science students, engineering students, students in the business field, everywhere. One of our main things that we do is developer communities, where students can learn about all sorts of technology, and they can use these technologies and learn for the work field and for personal projects and to better their skills. So we have AI, we have web development, mobile, and competitive programming with Dr. Geary, where he teaches you how to kill your interviews. We also do a whole bunch of workshops and collabs. We're planning on doing some hardware events with IEEE. We're working with CodePath this semester for Android development, and we're also going to be doing some professional development workshops as well. And finally, we also do some community events as well. We have a Discord server, and we offer a whole bunch of cool events. We have like game nights, movie nights, a karaoke night where you could come in and you could hear me sing my questionable music. And we also do a whole bunch of projects and lead code grinds together to get prepared for the future. Next slide, please. Um, Coming this semester, we have a huge event for students, which is the annual Google DSE Solution Challenge. It's presented by Google, and you can work on a project that where you can give back to your community, and you can make awesome projects. You One of the main requirements is that you use a Google technology, and you can use a whole bunch of cool technologies. Like for instance, what we're going to be learning here in this blockchain workshop. This is one of the a really cool thing that you can implement into your project, and um, yeah, that will benefit the community, and they're going to be based off these goals here. Next slide, please. And if you do win the solution challenge, you get awesome prizes that you get access to, mentorship from Google, and a whole bunch of awesome things. So if you want to register, make sure to register with the link in the bio here. Go to fiu.edu/FIUSC sign up, and our access to our links are right here on the bottom. Thank you all so much.
Thank you, Asar. Daniel, do you want to jump in this one, or do you want me to do it?
Yeah, yeah, yeah. Hold on, give me 1 second. Sorry, I'm in the car with Dino right now, and it was a little bit of an echo. Our bad. Yeah, yeah. So, anyways, guys, thanks for having me. So, yeah, my name is Daniel. I'm a former FIU student. I just graduated in summer. I majored in economics. I minored in business analytics. So I have some experience working with AIS, and I got a lot out of my experience with AIS doing the business analytics challenge and the blockchain challenge. So what Eduardo and some of the other guys and what we've been trying to really push is getting you guys set up with like blockchain workshops. And right now this one is definitely this is a introductory blockchain workshop that Ege is going to be showing us today. And the idea is just to be a primer of getting to some further topics and even some more technical topics. Like, for example, we're probably going to have in the future a workshop for like Solidity programming, which is if anyone's familiar with smart contracts, is basically the programming language used to develop these smart contracts. And moving forward, we're just we're really looking forward to working with AIS, UPE, and DSC to facilitate blockchain development at FIU and blockchain education as a whole. So if anyone is interested, also we have a couple of we sort of have like a developer dojo slash like internship where we teach developers blockchain topics and blockchain development. So if anyone's interested, please feel free to message me, email me at simply just daniel@blockchaincenter.com. I would love to tell you more about the program.
Mention the hackathon.
Oh, yes. So we're also having a hackathon that's starting tomorrow. It's a 3-day event. I'll also include a link to our YouTube channel. We have live stream panels from industry experts, and we also have some technical workshops for our audience. So I'll go ahead and link some information to that for our Eventbrite and our YouTube channel, so you guys can check it out if anyone's interested in participating in the hackathon. If any of you guys have prior blockchain development experience, but either way, we would love anyone to just get started and start building. We're gonna have some of these technical workshops, so hopefully you can learn something while the hackathon's going. So maybe you could just start a little project. So anyways, guys, I don't want to go on too long, but yeah, looking forward to working more with you guys. Thank you.
Daniel, actually, some guys asked you about how they can join the hackathon.
Oh yes, I'm gonna include an Eventbrite in the chat, and it has a link to the landing page to sign up for the hackathon. And once you guys sign up for the hackathon, we'll go ahead and send you an email to join our Discord server, or I'll also put a link to our Discord server. So that's basically how we're going to communicate throughout the hackathon. So I'll go ahead and I'll drop that information shortly.
Okay. So can I also join?
Yes, of course. And also, Ege, please introduce yourself. Oh no, you already introduced yourself. But yeah, Ege is great, guys. Ege really knows his stuff. He's him and I, we've known each other since early 2020, and we've talked a lot about things. And you're in great hands, guys.
Okay, so
Thank you, Daniel.
Thank you, Daniel. So without further ado, we're gonna start our session with our first blockchain session with our host Ege Tekiner. Please, thank you for coming, Ege.
Okay. Can you please let me share my
Yeah,
screen?
sure,
So
no problem. Go ahead.
Okay. So hello everyone, I'm Ege Tekiner and I am tonight's host for you. Tonight I'm going to give some introductory information about blockchain and why we do blockchain at the end. This is actually a little old presentation. This reason I could not add the other student organizations to the introduction page. Please, guys, accept my apologize. But who am I? I am a master student at Florida International University, and my primary area is blockchain. Everything about blockchain, abusing crypto, but I am especially working on the abusing cryptocurrencies and their usage areas. So actually, we are something like hunting the bad guys at the lab. So, uh, th- but tonight, of course, we won't talk about it. I am working on blockchain technologies for more than 6 years. Don't ask me. I don't have bitcoins. I I spent all of them, I can say. And that's all. Please do not hesitate to interrupt me if you have any questions. You can always interrupt me. Just raise your hand. Unmute yourself and talk. Ask your question. I'm I'm very okay with that. And please enjoy. Let's start. So tonight we will start at just give me a what is blockchain? Okay, it's the actual main question of tonight. But I really would like to start with the formal definition, so we handle the boring part before we go through the funny part. So a blockchain is essentially a distributed database of records or public ledger of all transactions or digital events that have been executed and shared amongst participating parties. Long definition. And basically, Bitcoin is a shared database between all parties in the network. Okay, Bitcoin, it has a good price.
Hey,
How much is one Bitcoin
sorry
right
to
now? How much is
interrupt.
that?
Um, can you,
Yes.
is a public ledger a synonym for basically that database of records, or does a ledger mean something else?
Actually, public ledger is the database of all transaction events in the network. But why is public? Because everyone can see it and have it, possess it in their own local network. This reason
Okay,
we are calling that as a public ledger.
thank you.
Okay, uh, no problem, man. Each transaction in the public ledger is verified by consensus or majority of the participants in the system. Okay, we handled the boring part. Okay, most basic definition of blockchain is a distributed ledger in which all transactions are securely recorded. Means that think about the transaction, banking transactions, messages, messaging applications, and everything is a transaction. We have a public ledger that can securely record all of them, but how? How? We will talk about it tonight. And before, let's talk about the little history of blockchain, because actually we should first understand the idea behind it, why we need that kind of technology. Yes, Bitcoin is expensive, but why? Yes, people love it, but why? We have a blockchain mentioned here, but why? We need to talk about it. In year 2008, an individual group writing under the name of Satoshi Nakamoto. Why we are talking about group? Some scientists that specially working on the writings and the language say that there is more than 3 person wrote this paper. This reason we are always talking about a group, but we can never know because no one don't know who is Satoshi Nakamoto. So we don't know who the inventor, or we don't know who is inventor of the blockchain technology and Bitcoin, and the most richest 24th man or something in the world. A peer-to-peer electronic cash system. Okay, this paper describes a peer-to-peer version of the electronic cash That would allow online payments to be sent directly from one party to another without going through a financial institution. Oh, okay. We don't need a bank then. Hmm. It's also good, something good. Let's keep in this mind. And Bitcoin is the first realization, implementation of this concept. So you guys would like to ask me, why do we have this Lehman Brothers picture here? Actually, Lehman Brothers. By the way, I don't remember that I was in high. I don't even high school. I was in a sixth grade or something that time, but and America going to the very deep economical crisis at 2008, and it was the beginning. Lehman Brothers bankrupt was the beginning of this process. Everyone said that. I don't know. I just read about it. I cannot say this is this. I don't remember. I don't even remember. But okay, never mind. The thing is, after these bankruptcies, people lost their money, not losing in shares or something another. Their money just gone. Poof. Because the databases of these companies deleted. Oh, so let's think about it. Bank of America, Wells Fargo, Chase, lots of banks around there. What will happen if one of your banks delete all of their databases? What will you do? It could be beneficial for you if you have if you have a mortgage or something, but it won't be beneficial for you if you have a lots of money at the bank. What would you do? What can you do at this point? You can sue them. Okay, it may take tens of years. Okay, it's a bad thing. It's the point why we need blockchain and these cryptocurrencies, because we don't want financial institutions. We don't want government rules. We want to set our rules for our system. And we want to make this happen together, not parent to someone, some company, or some individuals. And this picture is the actually Bitcoin peer-to-peer e-cash paper. It was the email Satoshi Nakamoto sent at 1st of November 2008. It was the actually beginning of the how can I say, beginning of the legend. So let's go through. Okay, now world cryptocurrencies is the label that is used to describe all networks and mediums of exchange that uses cryptography. It's the important part. We are talking about it later. To secure transactions as against those systems where the transactions are channeled through a centralized trusted entity. We centralized trusted entity, banks, exchanges, governmental organizations. Don't just think about the money. You should also think about the data. For example, there is a very funny story from my own country, Turkey. And the thing is, there is a one guy. They broke up with his girlfriend. I believe he had an affair, something like this. And his girlfriend is working on the department of something for the population. And this lady just go into the database and change his boyfriend's situation as a dead person. In the government side, the guy is dead. All of the bank accounts closed. He is not exist anymore. He even has a place in the graveyard. So think about it. He he is the, I believe, the most important example of why we need to keep this data publicly and secure, because someone can change your data and you become dead at the government side. You can live, yes, but you're dead. Think about it. You are dead. You don't have any ID. You cannot go anywhere. You cannot open a bank account. You are dead. And it's very hard to change it because you must prove that you are not dead at the court. Okay. Your Honor, I am not dead. A few months later, okay, the author of the first paper wanted to remain anonymous as a Satoshi Nakamoto. We don't know, as I said, we don't know who this guy is. And has no one knows Satoshi Nakamoto to this today. He is the 27th wealthiest person in this world right now because of his Bitcoin amount, or her or their, we don't know. But this group is extremely wealthy, but they never spent their Bitcoin since 2010. They made some transactions to some other parties, but little transactions, something like introductory transactions. But these guys are anonymous right now, or this guy or this lady is anonymous right now. A few months later, an open source program implementing the new protocol was released that began with the Genesis block of 50 coins. 50 coins, I mean 50 Bitcoins. And actually, there is a very important part of this sentence: open source program. Everyone can see the source codes of the Bitcoin. Everyone can change some little parts of it or don't change and run it again and create their own. You can create your own Bitcoin right now. Of course, it won't be the real Bitcoin. I mean real. What I am talking about is a real. The Bitcoin we are talking, the Bitcoin who the value is equal to 30 something $1,000. 31, $32,000 right now, something like that. It's crazy. So anyone can install this open source program. Anyone. Just go to GitHub, GitLab, bitcoin.org, and download the source code and run it on your computer and become a part of the Bitcoin peer-to-peer network. Of course, it's not that easy because you need to have lots of space in your computer. There are some, of course, handicaps at this point, but okay. It has grown in popularity since then. Popularity. It's also something another because Bitcoin do not have any real value. Who is actually defining the value of Bitcoin? Why people spend 30 something $1,000 by Bitcoin? It's some another point, and it's about popularity. We will talk about it later. But first, let's talk about the centralized trust current model. I talk about quickly.
I'm
The
sorry.
digital economy is based on the reliance on a certain trust. Yes.
Okay, we don't. At least for me,
Yep.
the. Okay, now it is. Now it is open. Go ahead. I couldn't see the slide. Now I can see it.
Oh,
Thank you.
okay. 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 Current digital economy is based on the reliance on a certain trust authority. What I am talking about, the banking applications or money applications, something like Venmo, Cash App, Money App, I don't know, all Zelle, all of them, is actually rely on a central trust authority, these banks. You must accept their terms. And actually, your money is not belongs to you. Your money is just an entry, a little entry, some little bytes in their data set. It's all you have. All online transactions rely on trusting someone to tell us the truth. For example, I want to send $5,000 to Eduardo. Okay, I love this guy. I want to send it. And I open my Wells Fargo banking account, send the money, and it says, okay, I sent the money. Don't worry. But Eduardo called me after that. Hey, yeah, where's my $5,000, man? And I told him, okay, I sent you. And he can say that I didn't receive it. And we just hope it's true again. But it's an important part. We just hope that they are telling us the truth. Someone inside the bank can interrupt the transaction and do it can email the provider telling email has been delivered. For example, uh, your ex-girlfriend or boyfriend is a good hacker, and the day you need to send your final project to your professor, it changed some little things on your computer and hack your computer, and you just think that okay, I sent my final project. This it's end of the term, and day after you received an email from professor where your term project failed for us. Think about it.
I'm sorry, Ege, you're getting a lot of lag,
It
and
can be
we cannot listen to you correctly. There's a lot of lag at the moment
sorry.
that you're speaking. There's a lot of lag at the moment of your
Oh,
speaking.
oh,
Can
okay.
you repeat
What? How is it
the
right now?
now it looks now that sounds good.
Okay,
Okay.
okay. As I said, it can be email service provider telling us that our email has been delivered. For example, Outlook email service. Our university uses that. And for example, your someone inside the Microsoft don't like you, your enemy, and this person can interrupt your emails and say, and your email service provider tells that, hey, your email has been delivered. Okay, you are good to go. How we can know that it's really delivered? Is it possible? We still just need to trust the central authority. This is the problem. And it can be a social network such as Facebook. There is lots of problem about WhatsApp right now, WhatsApp and Facebook, telling us that our posts regarding our live events have been shared only with our friends. Is anyone believes that? Are you believing that?
No, I don't know.
Oh. He also don't believe that. Okay. It can be a bank telling us that our money has been delivered reliable to our dear ones in a remote country. Think about Venezuela. Your bank tells you yes, your money delivered. Okay, there is no problem, but your loves, your dear ones never receive money due to the government rules. These are the problems of the central authority. We must always trust them, and we don't have another option to trust them in this economy. Let's go ahead. And there is another important thing is, think about hacker. It's always the best place to stealing some cookies is from cookie jar. You will always be seeking for the cookie jar to steal some cookies. As a hacker, I would always go for the banks to steal some money, right? I wouldn't go for me because I don't have that much money. So, and they have less. So, what if one hacker, one if another third adversarial harm your data and change your possession amounts? What can you do? It's a data set. It's just a data. It can be changed. We are changing our data every day. Every time we receive or send data, receive or send money, we change our data set. It's the truth. And if some another third party able to do that, it's not okay for anyone. Is anyone have any question till to that point? And I know, yes, we all have bank accounts, and we will all have. We won't close our bank accounts. Don't worry.
And
Eduardo, do you have a question?
I do
No,
have a
no,
few I do have a few questions, but I don't know if it's
Of
better
course.
just to wait to the end.
no. Go ahead, Omar. You can ask the
Okay.
questions right now if you liked.
I mean, this is a
Okay.
very dummy question. This is my first time that I'm actually knowing more about these things. But just the fact that we already have, yeah, as you mentioned before, a central trust of authority, and having
Mhm.
that hasn't stopped the amount of frauds and problems that we have, on e-commerce on a daily basis. What does
Yeah.
this model that you're presenting has to offer to us that brings more security? Because if by having a central authority, you said that it's just exceeding our privacy and our rights to do whatever we want to do,
Mhm.
what is this system offering you? And I like
Uh,
like
y-
like
of course.
compensating.
Actually, of course. Thank you for the question. Of course, banks and other governmental. There is an NSA in United States. These guys spend billions of dollars to keep United States secure environment safe from others, from China and Russia, not from United States government. Or it's same for the old countries, MI6, KGB, and Turkish intelligence communities, and all of them does that, of course. It's about being a country. I cannot say they should not do that. I cannot say NSA should not be exist. But the thing is, uh, we must trust them. This is the problem. And last time people trust them at 2008, they couldn't take back their monies. And we understand that government won't always protect us. So we need a system that protects everyone, even government. This is the main goal of the blockchain and blockchain based environment, keeping everyone safe except adversarials, keeping everyone happy except adversarials and except dishonest third parties. Because actually it is the main point of the word consensus. Make
I understand.
everyone happy except dishonest ones. This is the main point of the consensus. And I'm 100% okay with the security level of these companies and everything, but everyone can be hacked. We saw SolarWinds, FBI, NSA, CIA, all of them hacked together due to one another third party.
The fair blockchain itself is
But
basically
and I don't say blockchain is not hackable, but blockchain is recoverable. It is the point. Okay.
Alec, do you have a questions or a comment?
I'm saying that blockchain as a technology will lead to a more how to say, move to more aged society, as well as a society that will be more fruitful and provide and more proficient in providing itself compared to most of the us in the past, because people will actually have wealth in their chain in his name, wealth in their name, as well as wealth and within their account, compared to bank accounts or chase accounts or money or both where both have much sort of money in them. So what I'm trying to say is that blockchain is more secure than your average bank account. Is that correct?
That
Actually,
is
I like your sound interrupted. I couldn't hear your question properly. Is it possible to repeat it? I'm sorry.
I'm saying is that blockchain will lead to a more protected society, as well as proper society, due to people having agency within their wallets, as well as at least having wealth in their secure in their accounts that's unhackable compared to like their bank accounts or their vaults or the safes.
Uh, Actually, Bitcoin addresses is another point. Yes, we have wallets, and we think that these wallets hackable, cannot be hacked by any third party due to some mathematical proofs. But every day, the capacities of our computers improves. For example, think about a couple months ago, we think that Intel's Xeon technology is the best in the market, but right now we have Apple's M1 ARM sets. And yes, they are hackable, but they cannot be hacked inside a, how can I say,
Traditional
meaningful time.
sense,
Sorry?
like they can't be hacked in the traditional sense. To the fact they require more like sophisticated applications compared to like the average account or average trading account or average bank account.
Yes, but just think about it. You can hack any blockchain data. You can really do that. And it's a very dummy way to do that, brute force. But it will take around 80 years.
Hmm.
And this is the problem. Yes, you can open as many accounts as possible and you can check your, for example, I am
I
giving some, I have several VIP customers, and these customers have millions of dollars as an asset. But and we are doing that. Yes, we are dividing their assets to different wallets, etc. But it's another part of the security, another level of the security. You, as long as you are using something trustable, but I am talking about trustable, uh, accepted by the community, you are safe. You don't need to open lots of accounts, and you do not need to actually worry about hacking. Okay?
yes. And can I
If
ask,
it,
make a follow-up question?
yeah.
So how about if like somebody from like in a Latin country or just in a third world country has this technology and they want to store most of their wallets or accounts in that particular technology, wouldn't they
Uh,
be safe from hacking or from investigations from like other foreign powers?
uh, Actually, the thing is, as long as everything about it is rely on private case. I will explain it later. After I will explain that private key cryptography, we can talk about it more about it. Okay?
Okay, I want to
Okay.
have this
Just
conversation though, but
little patience. Okay?
patience.
Thank you. And okay, let's go back to the slides. Uh, okay. What is distributed consensus and anonymity? Yes, and block and Alisa, yes. Blockchain ledger history can't be changed. I will explain it why in 3 4 slides. It's true. And distributed consensus and anonymity. The thing about anonymity is we have right to become anonymous. I am not talking about the hacker guys, but we need to have this right. We need to have the, how can I say, opportunity, choice to not to share our identity. And blockchain provide that. In blockchain network, we are just numbers. Okay, you can, of course, you can share your identity. Hey, this number belongs to me. You can say that, and you can even prove that. But as long as you don't want to do that, you won't, and can become anonymous. You can have 5,000 Bitcoin, millions of dollars, but you can't still be anonymous. Stay as anonymous. You don't have to do that. Of course, when you want some cash money, cash United States dollars, it's very hard to keep anonymous. But yeah, as a Bitcoin environment, we have right to stay as anonymous. And distributed consensus. Consensus, as I said, consensus means that make everyone happy, make everyone satisfied, satisfy everyone except dishonest third parties. And in blockchain, we have consensus model that makes this all of these transaction things work while makes everyone happy. And while we are doing that, we can eliminate the third parties. This is the thing. And let's talk about it a little bit more. So, blockchain. Yeah. Now we are diving into a little bit more specific things. Blockchain structure consists of a chain of the blocks. Blockchain actually chain of the blocks, where each block has two parts, block header and transactions. A block header consists of the following information. Hash of the previous block. Don't worry, I will talk about it in the next slide. Version, version of the blockchain software, etc. Normal version of your software in your computer. Timestamp is very important. Timestamp is very important entity because we need to know when exactly block published to the network to be able to follow the uh, transactions. Difficulty target. Just after I will explain to hash, I will explain difficulty target to you. Nonce will come with difficulty target. And the root of the Merkle tree. Root of the Merkle tree is just basic combining of all transactions. You will understand in couple minutes. Let's start with hash. Hash? What is hash? Is that eatable? No. We are using hash algorithms to map any kind of data to a standard size of data. Okay, what I am talking about. And just think about it. This is just please have a look at this little screenshot. The SHA-256 is one very well-known hash algorithm.
¿Qué te iba a llamar, mijo, yo? ¿Qué te
Sorry?
dijeron?
I think he was Omar. You were unmuted.
Can you guys see my screen right now?
Yes, we do. We do.
Okay. Okay. Perfect. Please have a look at this SHA-256. It's a very well-known hash algorithm. It's the name of the algorithm, not something special. It's just name of the algorithm, and we are using this algorithm inside most of the blockchain applications, of course, with the Bitcoin too. So I just talk about the Bitcoin's PDF, Bitcoin's white paper, and this Bitcoin white paper has how much? 3,500 something words and 20,800 something characters. And the hash thing is, look at this, thousands of words, thousands of characters, just looks like this, B16741, this long. And I just delete one letter, just one letter, Bitcoin PDF, Bitcoin.pd, for example. Just I delete, but choose just one letter inside the whole document and delete it. Please have a look at the hash output at the bottom. B7AC finished with AC24 cannot be recognizable. So both are the same size. If you even put 100 gigabyte of data to there, it will give you give output something like this in this long. It never go. It will never be longer. It will never be shorter, and you cannot find the real data from this hash output. What I mean, as long as I won't tell you this is the hash output of Bitcoin.pdf, you will not be able to understand it's the hash output of Bitcoin.pdf, because you must do a brute force, and it will take around, as I said, 80 something years, 84, 85 years with the high-end computer in the market. If you have that much time, good luck, because you may not all find also. Fixed size rule, as I said, it will give only one letter, give how can I say, 100 gigabytes of data. It will only give the same size, 128 characters. It will be same size. And unique output rule. Just have a look at. I just deleted one letter, and it's totally different right now. You can say that these two things actually it's almost the same thing, only one letter different. I just delete some a from some inside some sentence, and totally different. I do not expect anyone to understand hash algorithms properly, but it's just a little information about what we will talk about now. Does anyone have any question about hash?
Or any other questions in regarding of what Ege has said in the past? Feel free to ask the questions in the chat or unmute yourself.
Okay. Okay. So, chain of blocks. Blockchain, chain of blocks. Blockchain, chain of blocks. Actually, blockchain is just a fancy name. Actually, it's just a chain of blocks. What does that mean? Let's think about it. We have thousands of blocks in a row. And every block includes the hash value of the previous block. If you change a content of any block, if you will change even one letter, for example, if you will change even one letter from this block, the hash value inside this block will change, right? If the hash value of this block will change, the total hash value of this block will also change, right? If the hash value of this block
Yeah, is it just me or can you guys not hear him?
No,
Yeah,
he
guys,
got disconnected. Yeah.
Oh, okay. I thought it was.
Okay. No, I thought it was me as well, but no, he got disconnected. Okay, he
Okay.
got kicked out. Oh, here you are. Hi, Ege.
Hi.
All right.
I'm
All right.
sorry. The guys just told me I'm disconnected. Where did you guys start?
Okay. Now we can.
I believe there is some weak Wi-Fi connection there. Actually, I didn't have lots of time to try it. I'm so sorry about it.
No, don't worry. Okay, now we can listen to you perfectly.
Okay, so what you guys hear last?
Okay, so it was about the hashing. If you change a value in one of the blocks, it will change the value of the next block, and then it will change the value of the entire block itself.
Yeah. So you will break the chain, Eduardo. Don't do that. You will break the chain, and everyone can see that. Someone can see that. For example, you have a chain of blocks, and someone broke it. Hey, someone changed my data. And you can just turn back all the blocks and find which blocks changed. It's very easy, but effective. Extremely effective. So, Alisa, did you understand the answer of your question right now? Is okay? Perfecto. Does anyone have any question? Anyone?
Mm, okay.
Okay, let's go. Okay, distributed data set, database. Okay, we have chain of blocks there. Okay, it's perfect, perfect. But if it's in, for example, if I am the only one who knows this chain of blocks, it won't matters, right? It won't matters. So we need to share this data with anyone, everyone. So if someone will break this chain, everyone can see that, right? For example, everyone in this network, in this lesson, knows has the chains of blocks, thousands of chains of blocks. And I will just change one of them and say that, guys, this is the new blocks chain. And everyone will say, hey, yeah, you changed the data, man. Hash values won't fit. And everyone actually has the real data. So actually, at this point, as long as 51% of the network remain honest, no one cannot do anything to our chains of blocks. And actually, it's also impossible to, uh, almost impossible, I am telling that, if you don't have super Chinese supercomputers, and and if you have this computer, you won't change the blockchain. I don't know, but uh, as long as 51% of the network honest, there is no problem, guys. And no one cannot actually calculate the new hash values of all of the data and create new chain from scratch. It's extremely expensive process. It, for example, recreating the Bitcoin blockchain will cost you billions of dollars. You can't do that, basically. Okay, distributed database. Okay, guys, to be let's be honest. Who downloaded something from torrent? Anyone? Really? No one did not download something from torrent?
I have done
Okay,
it.
Eduardo.
Yeah, I
Eduardo.
have done.
Okay. Juan, Martin. Okay, perfect. Okay. Firas.
I've
Okay.
done legal ones.
Okay, you guys, can you guys also please your addresses so I can, police officers won't have less of trouble. Okay, in block, okay, it was a bad joke. Okay, in peer-to-peer in torrent, actually, you do not connect some server. Actually, you just download your data from anywhere inside network. For example, when you go through to any torrent, by the way, torrent is not something illegal, guys. The things you download from torrent is illegal. So you can actually download some openly accessible documents, and you can also download some, for example, Linux distributions from torrent. There is no problem about it. You can do that. It's fully legal. But when you download the Avengers Infinity War from torrent, yes, there is a problem because there's a copyright issues coming in. Okay, so let's go through. And in torrent, actually you connect everyone else in the network and download some different parts of the data from them. Actually, there is only one data. For example, you are downloading openly accessible movie, not copyright one, openly accessible movie. And actually you take the first 5 minutes from some guy, second 7 minutes of some another guy, last 2 minutes from some another guy. Actually you download this data from different parts. It's something good. And in blockchain, actually everyone connects to each other. So in the central approach, we only have a server. Think about it. Netflix. These guys making me mad. Netflix deleting your some TV series or movies from library when their contracts So you cannot watch it anymore. Because and they are deleted. And you say something that you call the CEO of Netflix, you can do that. And why did you
Can
delete the Big Bang Theory from United States servers? And he
I'm
can say
sorry.
that. Sorry.
I'm sorry, Ege. What did you try to say that it got? At least for me, it got lag. I
Okay.
couldn't listen to what
I'm
you said
trying
with
to
that
say
about the
that.
Netflix. Uh huh.
Okay. I'm trying to say that Netflix sometimes deletes some TV series from our libraries and from their database.
Mm-hmm.
And when you call the CEO of the Netflix and says that, hey, why did you delete this TV series? And he can say, I wanted to. Okay, man, good. Have a nice evening. Say hi to children. You can't say anything because they are the central approach. They are the central authority and they are central servers. If they don't want to have something in their servers, they won't. They can just delete it. And it's the single point of failure at most things. For example, uh, think about it. Your all data of your bank just poof, delete. All mortgage credits, all banking history, all banking account, everything you have can go in seconds. And there is no if they cannot take their data back, there is no point. Single point of failure. It's gone. Your money gone. You cannot have it anymore. This is the problem. But in peer-to-peer network, as long as someone keeps sharing this data, we can have it. For example, torrent guys, think about it. Uh, you are trying to download Max Payne 2, very old game, and you are trying to download Grand Theft Auto 5, very common game. You can find more than 30,000 guys who will sharing this game, right? But you cannot find even 20 guys that's sharing Max Payne 2 because community does not want to share it anymore. So in peer-to-peer approach, as long as community want to share it, it's shareable. When they don't want it, it's not. It's the main point of the peer-to-peer network. And actually, uh, this is the network we want to use, distributed network. So we have centralized, decentralized, and distributed networks in standard network topologies in CS world. Centralized, everyone has their own little network.
Can you guys listen to him?
No.
Sorry?
Okay. Um, can you repeat what you tried to say with the centralized egg again?
Centralized,
There's a
for
weak
example.
connection. Mhm.
Okay, we Netflix centralized. Netflix is the center. We are the nodes. We banks centralized. Bank is the node. We are the guys. We are the nodes. We government. Government is the center. Center. We are just the little citizens. But when we think about the decentralized, it's something more something consists more freedom. For example, think about the United States and the states, Florida, California. Everyone has their own little network, but at the end, everyone connect to the federal government. It's something like decentralized network. Yes, multiple authorities, but at the end, they connect to one authority. And it's also problematic. We know that. But distributed, they look the distributed. This guy can connect to this guy through thousands of paths. But at this network, this guy can only connect with this guy through this guy, right? It is the problem. For example, this guy, if this guy cannot connect, if we cut this guy's connection to two of these guys, it also cannot connect, but it can connect to another place in distributed network. They can always come back. You can always connect to this guy, this guy, this guy, this guy, this guy, any of them. And think about, for example, in Bitcoin, think about it's 25,000 of them. You can connect 25,000 different little points here. It's what we call distributed. For example, when this guy says something, this guy can hear, this guy can hear, this guy can hear. But when this guy says something, if this guy don't want, no one in the network won't hear. This is why we want distributed networking inside our blockchain networks. So, and actually we call them very funny name. We call them with very funny name, gossip network. This guy, think about this guy, says something. Hey, Ege give Eduardo 25 Bitcoin. Eduardo is also rich now. This guy says his neighbors. His neighbor says these guys, these guys, these guys, these guys. Everyone says they're neighbors. And at the end, everyone will know that Eduardo has 25 Bitcoin. Send it by Ege. Okay? And surprisingly, it's happened into, think about 25,000 nodes. And it happened in 10 seconds, 15 seconds. It's that fast. When we talk about money, yeah, it's that fast. Everyone loves it. So, is anyone have any question about our networking approaches? Firas, Alisa?
Hypothetically speaking, if let's look at that sensor node and the distributed one.
Okay.
Let's say it makes a transaction and it's going to alert everyone, well, all of its neighbors, immediate neighbors.
Mm-hmm.
This is very hypothetical because I don't even know if the technology exists for it, but would it be, or do you think it would be possible for someone before it reaches its immediate neighbors to intercept that and then change it to whatever they want?
Yeah, of course it can be happen. It's a very good point, but for example, this guy intercept this guy, this guy, this guy, and this guy, right? Take news from it. But this guy can also have take this news from this guy, 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 everyone else. So when he receives different names, for example, this guy says, Eduardo, take 50 Bitcoin, but everyone else says, Eduardo, receive 25. He said that everyone says 25. You are a liar, he can say. And he can actually cut its connection. Bye-bye. And everyone can cut their connection with this guy, right? Because he's a liar. He's an adversarial. So think about it. Everyone, actually, we just say that, bye-bye. We don't want you anymore. Bye-bye. It's done. There is no more adversarial because we don't want it here. It's what we are talking about, the community and honest majority. As long as 51% of these points keep honest, they can mathematically, they can actually eliminate all of the dishonest points, nodes. Okay?
Okay, sweet.
Perfect. Any other questions?
Quick one. So the verification process of blockchain is basically kind of like a crowdsourcing technology. You're relying on the masses to certify one person's thing. Okay.
So consensus. So when we eliminate central authority, actually we have a problem, guys. Okay, we kicked the banks. We kicked JP Morgan. Okay. We are free now, but so who will do the job? Who will do the job? It is the problem of the blockchain. Actually, it was the problem of every implementation of electronic distributed cash system. None of the other project could not be able to achieve that till to Bitcoin. Okay, so we need to do that. Okay, we eliminate the banks, we eliminate the government. We need to handle this job. What is the job? Keeping the records of the transactions, right? So we need someone keep tracking the transactions and put that into the blockchain as a ring of the chain and distribute it to everyone. Okay, who wanna do that? Asar, would you like to do that? Or Firas, would you like to do that? I believe no one don't want to do that. But yeah, it's a lots of job, thousands of transactions. Okay, this. Okay, we need to. Okay, I will give 50 Bitcoin every 10 minutes. How much will 50 Bitcoin equals right now? Let me check it. 50 Bitcoin. Lots of money. It's
Be like 150.
$31,000.
I want to talk to.
Okay, I will give you 1,550,000,000. $1,550,000. I'm sorry. So much number. In every 10 minutes to do that. Azar, would you do that for us?
I don't know.
$1.5 million in every 10 minutes, man. Good money. Very good.
I'll think about it.
But everyone wants to do that right now. This is the problem. And we need to choose someone. Let's sort all the nodes. Is it okay?
No.
No. Because you can be at the end of the queue and you may need to wait for 100 years. Now, I don't like it. We can choose any node randomly. Is it okay?
I agree.
Sorry?
I agree to that. We can choose any one.
Okay,
One.
so who will run the random number generator? Guys, I should say something like that. In computer world, there is no random actually. There is no real random. Only humans are random, not computers. Computers must consist of some logic. There is no randomity in us. There is no randomity in our universe. Only humans are random. In universe, everything consists of mathematics. You can regenerate everything except human mind. So I am asking you again. We can choose any node randomly. Is it okay? Because someone needs to write this randomicity algorithm. Is it okay?
I don't know if I agree completely logically with what you're saying, but let's continue.
Okay. Yeah. We can give everyone a luck-based puzzle. Luck-based. Luck-based puzzle seems fair. We will have a look at the next slide. But, yeah, luck. Lucky. Eduardo, are you lucky?
A little bit, I can say.
Okay. Are you okay with the luck? I will give you a puzzle. You cannot solve it with the mathematics. You need to be lucky. Okay. Is anyone have any problem with that? Luck.
Is sort of too, right?
Okay. Let's go. So what is blockchain consensus actually? In proof of work, some nodes in the network solve a hash puzzle. It's really luck-based puzzle. You can solve it at your first try if you are extremely lucky. To find a unique hash value and broadcast it to all other nodes in the network. How we can broadcast it? Distributed network, gossip. I will just tell everyone, I found the block, it is that. It's real, it really happens like this. You just yell like, Eureka, I found it. Bitcoins are mine. I'm rich now. I'm a millionaire. I wish. The first node broadcasting the valid hash value is rewarded with a block reward. But of course, I told you guys 50 Bitcoin, but it's right now 6.75 because this reward always getting reducing little by little. I will explain it later why block Bitcoin does that. And collect transaction fees. Transaction fees, looks yummy. Because while we are sending money via our banks, at least we used to pay some money to send someone. For example, for the Swift transactions, international Swift transactions, you need to pay less of money. UPS transactions, you need to pay less of money to them for international transactions. And it also has some transaction fees, but not like UPS and Swift. They won't take good part of your money. If it satisfies the difficulty target, we have a difficulty target. We will see it in just a couple minutes. It's accepted by all other nodes, and the node that found the valid hash value is rewarded. Eduardo, are you still lucky? Okay.
Not that much.
Okay, guys, let's make a little demo. So, come over here. Can everyone see my Visual Studio?
Yep.
Some codes?
Yeah.
Yes? Perfect. So actually, I just wrote a very basic, extremely basic mining algorithm there to show you guys how the things works. So David sent 4 Bitcoin to Angelina, transaction fee 0.001 Bitcoin. Okay. Ege sent 8 Bitcoin to Binance Cold Vault. Oh, I'm rich. I will make some trading. Transaction is 0.05. Guys, it equals a couple $1,000, by the way, right now. Binance sent 1 Bitcoin to Susan. Susan withdraw their assets. Naomi sent 0.5 Bitcoin to Frank. The transaction fee is 0.01 Bitcoin. Okay, perfect. And we have a difficulty target, hardness 4. Let's make it 3 for the beginning. So what is the difficulty target? When we put all these transactions together, we will have a hash value, right? Like when we take the hash value of the bitcoin.pdf, we will have a hash value. And Bitcoin network asks us to find hash value that consists some amount of 0 at the beginning of the hash. And actually, we will keep trying with the different node values. And at the end, we will find some data. Someone taking away my light right now.
It's really bright on the screen.
Yeah, I am looking like Messiah.
Yeah, we got to move back.
Okay, let's make hardness 3. And we'll see what this guy talking about. Oh, it found it. Oh, it found it 407 try. My computer just made 407 hash calculations and find a hash value that have 3 zeros at the beginning. 3 zeros at the beginning. It was less than a second, right? Less than a second, maybe half. Let's make it 4. Let's make it 4. 1, 2, 3, 4. It cannot find it. It was a little less than a second for the 3, but right now it's still looking. Yeah, it find it 73,058th try. Look at this. 00005 CE something. Let's try with
So
the 5. Just give me a second,
yeah.
please. Let's try with the 5. It will take sometimes while it's doing that. Let's talk about it. Actually, every time more computational join the network change the hardness level, difficulty target. Network actually, if there is more computational power, network increase the difficulty. If there is less computational power from the past, network decreases the difficulty. Why it's doing that? Because we want a new block in every 10 minutes. Why? Because Satoshi did like that. We don't know. He likes 10 minutes, maybe. We don't know. It's a very slow transaction for standard daily transactions because think about your Visa card. It takes less than a second to make a payment. But think about international transfer. It takes days. So for an international money transfer, it's much cheaper and faster. But daily transfer, it's a little bit slow, flat slow. So by the way, it's still looking for 5. I don't know when. We don't know. We can't know. This reason I am stopping it here. But I believe you guys take the idea. For the theory, it was less than a second. For the 4, it takes around 15 to 20 seconds. For the 5, 2 minutes, and we couldn't find it. Still couldn't find it. And right now, Bitcoin's difficulty target is 70. Look at all of those hash values. How much is that? It's from couple months ago before this Bitcoin hype madness began. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros. We couldn't find 5 zeros in couple minutes, and you need to find 18 zeros before anyone else. Before anyone else, and broadcast it. And I can say it's all based on luck. You can find at the second try, you can find at the fifth 5 trillion try. You can never know. Did everyone understand the difficulty? Any questions?
Martin, you had a question, right?
If
Yeah, but he answered it.
Oh,
and
okay,
if
awesome.
anyone, sorry, sorry, okay. And if anyone wants the code, I will be more than happy to share it. Don't worry. It's a very basic one. So, block broadcasting. Okay, I found the block. I found it. I need to broadcast my everyone to tell that I found the block. And actually, the first transaction inside this block is telling that Ege created 6.75 Bitcoin and sent it to his own wallet, taking the reward. Perfect. And I need to broadcast everyone. Hey, Eduardo, I found the block. Let's check it. Hey, Juan, I found the block. Hey, Alisa, I found the block. Hey, Fraz, I found the block. Hey, Raul, I'm sorry. Raul, I found the block. You need to distribute it to everyone. And when everyone says that, hey, Ego found the block. He really did. Perfect. And put that block to their blockchain, it means that your block accepted by everyone in the network and you receive your bitcoins. Bitcoin reward. And every and no, you shouldn't speak after me because after me there is nothing important. When I broadcast the block as in the first place, no, it's end. Everyone starts running for the next block. Everyone stop working for that block at that moment and start running from the other block. But what happened if someone just Eduardo is more luckier than me, that Eduardo, and he found the block just 1 second before me. 1 second before. I mean, half second before me. What will happen? What will happen? What will happen?
I guess that Eduardo's one would go override.
Yes, I feel bad. And everyone check their timestamp. Hey, Eduardo's blocks is okay. He solved the puzzle. Ege also solved the puzzle, but Eduardo is half second before Ege. So I'm sorry, Ege. Bye bye. Eduardo, you're the guy. And Eduardo will receive the reward. So you need to be fast, really fast. And fast means more actual device, more hardware. More hardware means uh, harder network. Harder network means more job. More job means more device. There is an infinite loop over there. And it's work like this. People spend millions of dollars to build blockchain network, to blockchain miners. For example, one of my customer in Turkey spent $1.5 million to build blockchain mining factory, and he is earning very well. Okay, transactions. Okay, we know how the network working, but before we finish today, we also need to understand transactions and how we can create. Bitcoin uses cryptographic proof instead of the trust in the third party. Well, who was the third party? Banks. We don't love banks. In Bitcoin, we are always trusting the mathematics. Mathematics is love. Mathematics is life. So when we wanted to send a Bitcoin to someone, we need to have this person's public key. For example, Eduardo should share his public key with me, and I will actually tell that this Bitcoin belongs to the owner of this public key. And I believe most of you guys don't know public key and private key cryptography, but very basically it is something like this. You have one private key and one public key. Someone encrypted with public key can only be released decrypt with the private key of this public key. So actually, in blockchain network, our private keys are our accounts. If you will lost your private key, you are no longer owner of these cryptocurrencies. There was a guy who actually lost the passphrase of $200 million worth Bitcoin. He he was a hype new last week or the week before. I don't know. Actually, the thing is, he is trying to recover his private key because without his private key, he cannot use it. So, as I said, private key is actually the master of public key. So when I send Eduardo's public key, these Bitcoins, I am telling that the master of this public key is now the owner of these Bitcoins. So as long as Eduardo have the private key of this public keys, of this public key, he is the owner of these bitcoins. But if he will lose it, he is not. I'm so sorry. And this is how we are working. I actually wanted to make a more deep and technical explanation of it, but we do not have lots of time here, and we shouldn't. The guys told me don't go so technical, but you guys can always reach me for more technical details. I'm always open for that. Okay, Eric, then we will talk later. So, and when I actually sent Eduardo these bitcoins, I broadcast it to the network. Hey guys, I, the owner of this public key and owner of this account, with my private key, I am proving my ownership. I, owner of this account, sending these bitcoins to owner of this public key. What is the meaning of the owner? The, the man or woman, the person will hold the private key of this public key. Okay? It's something like this. So guys, don't lose the private keys. It's not okay. Okay, Eric. Stage will be yours just before I finish. So this is how Satoshi explains what is the crypto, what is the things going. It took my 2 days to understand what's happening here. So just I put there for very basic explanation, because if any of you guys will wonder what is happening around this Bitcoin world and go through the Bitcoin's white paper, you will directly see this one at the top of the second page, and it's very hard to understand. Yes, Suleiman. Actually, the guy I was talking about. If you lose your private key, you have nothing basically. And people pays guys like me and other consultants to keep their private key safe. Yes, Eric, actually, it's like something like this. Don't lose a key. Give it to me. I will keep it safe for you. Of course, maybe I won't spend your bitcoins. Don't worry. Okay. And this is actually owner one signed the transaction with his private key, means that I am the owner, I am the possessor of these bitcoins. I'm proving it with my private key, and everyone in the network can verify this proof with their public key. I mean, as I said, it's a little bit technical side of this area. I can explain you in another channel what the real things happening at the background. Don't worry. So let's talk about the applications of blockchain and finish the slides. Financial institutions, of course, nowadays banks are attracting the Bitcoin and other cryptocurrencies because there's trillions of dollars there, more than $1 trillion of financial volume working around it, more than most of the 90% of the countries in the world. And banks no longer see blockchain technology as a threat to traditional business models, because they are trying to implement the blockchain to their business model. And actually, they are waiting for the regulations from the government. So it looks like we won't be able to eliminate the banks. And non-financial applications. guys, opportunities are also endless. We can envision putting proof of existence to overall legal documents, loyalty payments, notary, logistic, everything. But we blockchain is an expensive technology. What I am meaning with that? If you want fully distributed network like Bitcoin, it's expensive because Bitcoin currently spending more energy than some of the mid-sized European countries. And actually, 99% of this electricity goes to trash for nothing because someone else find the hash value. Someone else solves the puzzle, and all 99%, 99.9% of the energy goes for nothing. And it's, as I said, more power than Bulgaria, Romania, and some other developing European countries. So it's not very environmental friendly. So we are using different consensus models for them, but if we want fully decentralized network, we need to go with these things. Hey, luck-based puzzles, and luck-based puzzles are not environmental eco-friendly. But if someone will really find this consensus both eco-friendly and satisfies everyone, and if this project will market very good, it will be, for example, it will go with Bitcoin and Ethereum in the market. But no one could not do that yet. So Bitcoin technology has potential to become the new engine of growth in digital economy because Bitcoin technology has no borders. For example, United States government banned all of the Binance activities in United States, and Binance opened a Binance US, and they actually by other Binance institutions does not accept any transaction requests or orders from outside the United States, from inside the United States IPs right now. They are trying to make it localized for the taxes and other things, but this technology is borderless. So keep trying, guys. Smart contracts and smart property. And smart contracts are terms. For example, you are selling something to someone, right? Car, home, this webcam, this light. As an owner of it, you can sell it with smart contract, but you cannot change the smart contract. When you sell it, you must create another smart contract to take it back. There is no delay, there is no opportunity to deleting one smart contract. And smart contract using for very, very different approaches. With smart contract, actually, we can be able to do most of the thing between untrusted parties. For example, some guys running a casino via these smart contracts because everyone can see the everyone can see what's happening. Everyone can see the code because it's inside Ethereum network. Ethereum is another blockchain like Bitcoin. Everyone can see everything. Everyone can see all the transactions. Everyone can see when contract executed and finished, and everyone can see the transactions. So everyone is one thing, or companies that does not trust each other, or customers that does not trust, for example, as I said, I Facebook. Why? Because man, they have a bunch of data, and of course they are doing some things that we don't like with this data. But think about a decentralized social media happening right now. Everything will be transparent. We won't have any issue with because big firms, big apps, and these guys won't go out from this term. Everything inside the blockchain, and now everyone can that have a very little knowledge about programming can write and broadcast smart contracts in the Ethereum network. And by the way, every FIU student can come to our lab, and we will be more than happy to teach you guys how to write smart contracts executed by every node in the network automatically. So, as I said, when you execute a smart contract, there is no turning back. You finished. And smart property. These kittens were famous around 2007, and actually they are just a
Um,
little
can you guys listen to me perfectly or?
I can hear you.
execute.
Okay.
Sorry.
Okay, okay. I think you had a little bit of lag. Can you repeat what you were saying? We
Okay.
couldn't listen to you.
Okay.
Mhm.
These smart contracts, people create some smart contracts, kittens with this smart contract. And for example, you actually merge with another kitten, your kitten with another kitten, and you may have very expensive another kitten. It's something like this. It was a game. Some kittens, for example, this one, $115, because or actually you give cartoon, but yeah, you give with smart contracts and sell to people, and here
Yeah, can we
big money.
restart?
Yes, I'm sorry, Ege. Like we cannot hear you like correctly. There's a lot of lag.
Yeah, you're not coming through anymore.
Oh, well. In the meantime, Eric, do you want to jump in and say a couple things about yourself?
Yeah, what's up, everybody? I'm just here actually in the same physical yard as Aggie. Yeah, so I just wanted to give a quick talk on um, our dev workshops that we do during the week, and I thought it was really cool.
Uh,
Hello?
Okay,
go
now
ahead.
I can see you. Yeah, all right. Now we can listen to you, Ege.
Hello.
Are you there?
Okay. This like to thank you all. Thank you for your attention, and all of the other student communities to allow me to share my presentation with I hope you liked it, and you can contact me via my email address, and you can always show up at engineering center, engineering center. We are always we are always there, and we always have coffee.
Thank you,
Thank
Ege.
you.
All right.
So,
Thank you.
Eric,
Thank you.
I'll give it a couple of minutes for Eric to talk. If you want to jump in, go ahead.
Yeah, thanks to Eggy. He did a really great job. That was like a very thorough couple of workshops. But I just wanted to give a couple of minutes and just say hello to everybody. Is people still in chat right now? Who's still here?
Yeah, a couple. Yeah.
Let's see. So we have Eduardo. Who else here? Is Fira still here? Mark?
Yes.
Oh yeah, I'm still here.
Hey, what's up?
Hey,
Yeah. So how many people here do like back end or front end programming?
I like front end. I want to try to learn more about it.
Cool.
I'm a noob, but I want to learn as well.
Okay, cool. Who else?